This is going to be for part 1 of our Lab 3 project, an ANSYS for the airfoil at 60 Hertz. So loaded up our wind tunnel that we made from the previous project. So we're going to start here with this, and just to ensure that our lines stay equal, we're going to leave that like that. So what I'm going to do here, draw a circle. It's going to be centered on there at the beginning of our wind tunnel, and then we are going to dimension this rear line here to be 1.65 H51, 1.65, and now we're going to change the diameter of this circle to be 0.297 centimeters. And so now, so we can actually see it, we're going to zoom in, and we're going to draw a line here, and then draw another line here to here. And now we're going to make these tangent to the circle. Undo that. Wait until we get about here to here. Add a construction point there, construction point there. We're going to add the coincident restraint here to there, like so. And now go to modify, and we're going to trim. And now we have our airfoil, so we're going to trim that. We're going to trim this. We're going to generate the mesh. We need to trim there's our airfoil. Now we're going to go back to Workbench. We're going to update our downstream components. It's going to take a minute in order to update those components. Now we're going to edit our mesh. So now we have our new geometry loaded in. So because I was doing this on the previous part of the project, I had to delete out that name selection. So we're going to go up here, select, control click all of our surfaces there. Right click, create name selection, we'll call it Airfoil. And now sometimes ANSYS has an issue with the meshing. So what we're going to do is we're going to put in a refinement about this body right here, and we're going to apply it. Alright. We're going to apply it, and so now it's refined the mesh inside here to be about that body. So now we're going to generate our new mesh. And as you can see, it's gotten a lot darker. We have a lot more nodes around our airfoil. So now we go back to Workbench, update, and we're going to wait again. And so once you get in this setup, we're modeling this as a viscous simulation. As you can see, I just clicked the show progress down in that bottom corner because it's trying to update the solution. Again, because I was doing previous parts of the projects in this simulation all in one file. Now we're going to go to edit the setup. I'm using 4 local processes on this machine. So now if we go and look, we see our airfoil has loaded into our mesh. Models, want to again make sure that we're doing the K epsilon standard with enhanced wall treatment. Now we're going to set our boundary conditions. So for the 60 Hertz, doing Bernoulli to get the velocity inlet, assuming come out to 4.3293. It's the velocity magnitude. So now what we're going to do is click initialize and calculate, and then we will go through and get the actual project data we need afterwards. Now it's running all the iterations. I have the iterations set to 300 just to get as fine, give it the most time to converge. And we can see at 76 the solution converged. So now we need to go ahead and get all of our contour plots. Go to graphics, contours, and I already have them mostly set up, but you're going to go new. And so we're going to do the static pressure here along the surface body, so the interior here. We're going to display it. That's our static. And you do the same thing for all three. The only thing different now is we need to introduce, for velocity, is the vector setup. So, I already have it set up, but you're going to go to Vectors, New, rather than Edit, and you're going to choose all along the internal body. Set it to a 3D arrow so you get the full arrow, and then I scaled it up 2 and then skipped every 3, so that way, because when you originally do it, you will see a ton in there. So in order to overlay these, you're going to display your velocity, and you'll see that's the velocity on the inside. And so what you're going to do is you're going to add to contours of velocity, and now we have all the vectors of the velocity, and you see it changes up, and you can see where the airfoil is and it hits, and then how it changes. So that is for the vector. Now for the plotting of pressure and force. So in order to get the force that you're going to end up needing to calculate, go down here to reports, right click on forces. So remember now, for drag, the direction vector is going to be x equals 1, y equals 0, and we want it along the airfoil. And so then now down here, we've gotten our total drag force along our airfoil. This is not the drag coefficient we had to solve using non-dimensionally. We have to non-dimensionalize it in order to get the coefficient of drag. So now we do the same thing for lift, which is x equals 0, y equals 1, print, and now we get totally different things. And again, you non-dimensionalize this. So then, next, you can create a plot for pressure coefficients if you choose so. And again, x equals 0, y equals 1, and we want it about the airfoil, not anything else, the airfoil. And this gives us a pressure coefficient, which again is inaccurate to when you actually go and non-dimensionalize, but this is what you get. And now you do the same thing if you wanted the coefficient of lift, except it would be x equals 0, y equals 1. Now, in order to get the streamlines, you go to Results, Edit, and so you see it's loaded up, and again I previously already had the velocity streamlines in here, but in order to restart it, so this gives you a more accurate representation there of our velocity streamlines. But go up here, streamline, streamline 2, OK. And you would change the color and all that sort of stuff. Leave all this the same. And you would hit apply. Yes. We need to do it about the airfoil. That is the important piece. And then the walls. Those are our 2 pieces. There you go. Streamline 2. Start from velocity inlet. Apply. And now streamline 2 looks exactly the same. And that is it. That is the project. Or part 1, the project at 60 Hertz.